Okay. So in the last classes, we've started with 4th unit. What is functional dependency? And we've seen all this. So now we'll take example and see what is functional dependency. Able to see? Able to see the screen? Anyone can respond, please. Able to see the screen?
Yes, ma'am, now.
Yeah. So functional dependency. So today we'll see what is functional dependency. What is the meaning of function? What is the meaning of function? What's the meaning of function? This pen also, it's very okay. What is the meaning of function? What is dependency? Are you dependent on whom? For at least financial assistance to pay fees for your MCA, dependent on whom? On your parents, right? Yes or no? Yes. The same way here. Yes, in the same way here, what we are doing is in the database also, which values are dependent on which. So we are seeing that is what is called as a functional dependency. So we generally represent functional dependency as FD. What is that? That is called as a functional dependency. What it is happening? Okay. So X is functionally dependent on Y. What is this? X is functionally dependent on Y. What is X? X is called determinant. X is called determinant and Y is called dependent. What is Y? Y is called dependent. So suppose if we take X, Y are two variables. In this, suppose if I write 1, 2, 3, 4 and some values here. So if I say X is functionally dependent on Y. So what do we say? We say X is functionally dependent on Y. So then suppose let me say what's the USN number of Rashmi? What's the USN number of Rashmi?
3D19 MCA.
10. Okay. So Rashmi's USN is 10. Okay. So if I call Rashmi, what if I call 10, 1 BY, TD, MCA 10. So then who will respond to me? Who will respond to me? Rashmi will respond to me. Yes, madam. Okay. Okay. So this is about USN. Suppose let me assume that we have given roll numbers. So once you came to MCA department, initially you were not having USN. So before we have given you a roll number. Okay, let me assume that we have given a roll number for Rashmi as 10. If I call, I am taking class to you people and I call roll number 10, then who will respond to me? Who will respond to me? Rashmi will definitely respond to me. Okay, let me assume that. So there are, now we are conducting some seminar, some talk, expert talk. And we have combined MCA, CS and IS students. Okay, so then I will just call 10, roll number 10. Then who will respond to me? Who will respond to me? Either Rashmi will respond or CS 10 will respond or IS 10 will respond. Can I expect any response from this when I say roll number? Definitely no, because there are 3 students. Maybe the roll number in MCA also present 10. CS also there is a 10. IS is also a 10. Then how do we expect that people can respond? I can identify 10 is Rashmi. No, it is very difficult. So in that case, we cannot respond the 10 as Rashmi. So in that case, what we are doing, we are using something called as to uniquely identify each rows. Suppose if I want the details of Rashmi, what is Rashmi name, from which place she is, what is her native, what is marks, everything we take. So then I want uniquely about her marks also. What is her first semester marks, what is second semester marks. Then to identify uniquely, then we use something called as a unique ID. then we have something called as a functional dependency. How do we represent functional dependency? We represent functional dependency as FD. Short form, we write it as a FD. X is functionally dependent on Y. If and only if T1. What is T1? What is T1? T1 means one row. That is tuple. First tuple. So always what we have to see, what is X? First element of X, that is first row. So in this first row, X is column. Suppose if I say roll number, roll number of Rashmi is T dot X. Okay, if I say roll number of T dot X, then I should say that what is her name? Then I'll get T2 dot X. Suppose if I say X is a your roll number. T1 is what? One row. If I say T1 dot roll number 10 is there in your table, then suppose let me assume that there is one more T1 dot X, that is Rashmi. So Rashmi's value is repeated twice. 10, 10 I have given. Then what? Then what should be? Then what should be same? Then T1 dot Y should be equal to T2 dot Y. So if I say in the table, I have Rashmi's value one time 10. Yes, what is this? This is T1 dot X. Okay, that is T1. That is T is what? T is first row. T2 is what? Second row. Even in second row also, I have given a roll number for Rashmi. Then if I say 10 is Rashmi, then what is T2Y? I'll say Rashmi. What is T? This X is what? Roll number of Rashmi. What is this name of Rashmi? That is Y. If I say this is T1, then what should be same in T2? If I say 10, 10, T1 dot X should be equal to T2 dot X. Means what? If 10, Rashmi is 10 in first row, one row, then her name is what? We can find out her name Y, that is Rashmi. Okay. One more row, there is something called 10. Then what should be same? If I say roll number 10, then definitely we should have Y, that is her name should be Rashmi only. Yes, this is okay because the roll number is 10 and 10. But give me, if I say, if I mixed all students of MCA, CS and IS, if I say 10, roll number 10, then no one will respond and I cannot identify because there are 3 10s there. One 10 is from MCA, one 10 is from CS, one 10 is from IS. Then Rashmi also will not respond because Rashmi also say yes, and one person in CS also will say yes, and one person from IS also will say. Then how can I identify what is a roll number 10 and what is the name? Then it becomes difficult. That's what here you can see. When what is functionally dependent is if one value, that is in one row, if one column, that is 10, roll number is 10, then our name, if in case if there are 2 rows 10 10, if it is same, then Rashmi should be present. Then we say it is a functionally dependent. Yes, getting what I am saying? You are able to understand? Okay. So let us take one small table and let us see how we can take the thing, that is roll number, name, marks, then department, then course. Then what I'll take 1, 2, 3, 4, 5, 6 and some names A, B, C, D. And marks of student A is 78, 60, 78, 60, 80, 80. Then department, CS department, Triple E department, CS department, some Triple E, then IT or EC, some departments. Then course you have taken DBMS, then you have taken operating system, software testing, then one more thing. Suppose if I say this is the value what we have taken in the table. Yes, in this table we have taken these values. What is the first column? First column is roll number. What is second column? Second column is name of a particular student. And what is third column? Marks. What is next column? Department. What is next one? Course. Yes, so this is one table what we have taken. Okay, now we have to find out whether these tables, in this table, which is functionally dependent on which. So let us say, so suppose if I say roll number is functionally dependent on name. Okay, can you say whether one, if I take T1 dot 1, so what is T1 dot roll number? Suppose let me take roll number is 1. Is there any more roll numbers 1 with the roll number 1? No. Okay, then I can say this is fine. Okay, then roll number 1, if I say 1, definitely A will come, A will answer. But now, even in your class, there are 2 Deepikas. If I say A, see, you can see A. In first column also we have A, and here also we have A. Means what? In your class, there are 2 people who have same name, that is Deepika. So in the same way, you can see even B is also there 2 times. Means the names are repeated, but still what? Still there is a unique, that is roll number is not at all repeated. Is there anywhere roll number repeated? Definitely no. Then we can say that roll number roll number is functionally dependent on name. Then I can say yes, roll number is functionally dependent on name. Now reverse. Let me say name is functionally dependent on roll number. Can anyone answer whether name is functionally dependent on roll number? Can I say A, can I uniquely identify complete row in that table? Can anyone respond? If I say A is what? Deepika. If I just say Deepika, can I fetch her roll number? Can I fetch her marks? Can I fetch her department? Can I fetch her course? Can anybody? But here in this table, there are 2 times Deepikas, Deepika. Then can I uniquely identify? No. So name is not functionally dependent on roll number. So in the same way, can we move on? Roll number is functionally dependent on marks. Can we agree this? Roll number is functionally dependent on marks? Yes, definitely we can agree. In the same way, department is functionally dependent on course. Can we agree this? Come to department. Okay, in this department column, is there 2 times repeated department? Yes, you can say CS is 2 times repeated and EC is 2 times repeated. Yes, can I uniquely identify? No, then I cannot say this is not functionally dependent. Okay, now can we make it as reverse? That is, course is functionally dependent on department. Can I say this? Course. Come to course column. In course column, you can see C1, 2 times repeated. So means what? DBMS. If I say DBMS, can I say what is DBMS marks of Rashmi? Because there are 2 times DBMS. Then I cannot uniquely identify. Yes. So then this is also not functionally dependent. The same way, come to marks. Marks is functionally dependent on department. Can we say marks is functionally dependent on department? Come to marks. 78. There are 2 times 78. Then there is 60. There are 80. No, it is repeated. Okay, 78. If I say 78 is functionally dependent on C1 marks and department. 78 CS. Okay, 78 CS. Okay, I can These, because x is same, y is also same. Okay. Then 60 EC, triple E, 60 EE. Okay. Then these are also matching. Okay. No, but come to 80 here IT. But here you can see x is 80. It is 2 times repeated. If I say x 80, then 1 is in IT, 80 is in EC. Then I cannot say this is not functionally dependent. This what we have done. We have done for one variable. Just for one variable we have done. Okay. Similarly, can we do it for, can we, 1 second, let me save this page. I will present functional dependency. 1. Save. Okay. Okay. That was about functionally dependent for one variable. Okay. Now let us take 2 variables. So now can I take roll number? Okay. If I take now set, what is a set? Set of attributes. Now we have checked with only single value, single roll number, single variables. Now let us see whether can we do it for set of variables. That is roll number, then name. Is functionally dependent on marks? Can anyone say roll number, comma, name? Now we are taking 2 things. Can I go back previous one? Okay. I don't think so. Okay. So what we are doing here is, now we are taking for a roll number and name, then marks. So now I want to know whether roll number 1. Yes, because we know that roll number was unique. There was no repetition in the roll number. So then definitely we can say this is functionally dependent. So now let us take name and marks. Name and marks is completely dependent on course, functionally dependent on department and course. Is it fine? So then we have to check, come back, check the name, check their marks, and check whether which department and which course. Like this we check, then that is what is a set of attributes. Yes. So in the same way, I can check for roll number is functionally dependent on name, comma, marks. Then can I write, yes, this is functionally dependent. Can I write department course is functionally dependent on name? Can I write like this? Can I say it is functionally dependent? Department and course and name. In the same way, can I write roll number, marks is functionally dependent on department? Yes, we can. So like this we can say what are the functional dependent things. Okay, so next we move on to the some trivial, that is functionally some closure properties, types of, let us see about types of functional dependencies. Okay, types of functional dependencies. Okay, so now So what we are doing? First one, tribal. Second one, non-tribal. Next one, third one, multi-valued. Fourth one, transitive. Yes. So now we have to check types of dependency with this tribal, non-tribal, multi-valued, transitive. Yes. So let us see functionally dependent. What do we mean by functionally? X is functionally dependent on Y. If and only if Y is always subset of X, then we call how do we write? Y is subset of X, then we call it as a tribal. Yes, then we call it as a tribal. So then we say it is a functionally dependent. Then when do we say it is a semi-trial? So when X is functionally dependent on Y and X is subset of Y is not a null, or when Y is not equal to Y, then we call it as a semi-trial. Yes, these are some of the properties. So let us see some more properties. Save if D1. Can I go directly next? Oh, whether it is saved previous? No. Okay. Very bad. Okay. So let us see properties of that. First one is reflexive. Reflexivity. Next one is transitivity. So first we'll see reflexive. What do we mean? You would have studied in your maths also. If X tends to X and X tends to Y, then Y is subset of X. We have seen this. When X tends to X and X tends to Y, then it is Y is subset of X. Then what is transitivity? So transitivity, if X tends to Y and Y tends to Z, then X tends to Z. This we have seen about a transitivity. So then next one is what is next one? Armstrong argumentation. So what is the third one? Third one is argumentation. Argumentation means what? Making. Something is happening. So if X tends to Y, then X into A tends to Y into A. So let us see with the table. If roll number functionally dependent on name, then can I make roll number comma marks is functionally dependent on name comma marks? Can I do this? Yes, we can do. Then this is what is called augmentation or making. Then fourth one is what? Union. What is union? How do we say union? If x tends to y and x tends to z, then x tends to yz. Let us take roll number tends to name and roll number tends to marks, then roll number tends to name comma marks. Then we say it is a union. So what is union? So both the we are taking from both the sets. Next one, decomposition. Decomposition. What do we call decomposition? Splitting. So if x tends to yz, then we can write x tends to y and x tends to z. We can say, so suppose if I say name comma marks is functionally dependent on department comma course, then I can break this as name comma marks is functionally dependent on dependent and name comma marks functionally dependent on course. This is what we call as decomposition. Next one, sixth one, pseudo transitivity. Pseudo transitivity. So what do we mean by pseudo transitivity? If x tends to y and yz tends to a, then xz tends to a. So what we have done? Here you can see x tends to y and yz tends to a. Then we can say xz tends to a. Okay. So next one, composition. Composition is what? So if x tends to y and a tends to b, then xa tends to yb. Next one, next one, Okay. So next one is closure of attributes. What do we mean by closure of attributes? Suppose let us take R, A, B, C, D, E. These are the columns in the table R. So then, can I say functionally dependent? If A tends to B, yes, A is functionally dependent on B and B is functionally dependent on C, then C is functionally dependent on D, then D is functionally dependent on E. Yes, so then how do we say? How do we say A is functionally dependent? Closure. So first let us check with A is first one. A is closure to C. We know by the property of reflexive, A is itself. Then from the given functional dependency, if A tends to B, B tends to C, C tends to D, then we can say A also tends to D. Then because it is all functionally dependent, I can even say A is also functionally dependent on E. Yes, so then you can see A is functionally dependent on B. Okay, so now come back and check with another property. B is functionally dependent on D, and because then can I say B is functionally dependent on E? Can I say B is functionally dependent on B because of reflexive property? Yes, so this is what we can say about closure attributes of closures. Okay, so now can we say closure set? Suppose if I say X plus, what do we call? We call it as a closure. So what is this? This is a set of attributes. Set of attributes. So then what is this? This is contains set of attributes determined by X. Okay, so let us see one by one. A closure. What are the values A closure? A, can I say A closure for a set A? A is also closure. Yes, by the reflexive property, we can say A is closure to itself. Okay. From the given thing, we can say A is closer to B. Yes, because we have in our thing A is functionally dependent on B. Okay. Next one. Can I say B is also functionally dependent on D? Yes. Then can I say D? Yes, it is functionally dependent. And D. Yes, this is on A closure. Okay, now let us take two values, A, D closure. So then A itself, D itself, then B, C, and D. So how can we write? First check with A. What are the values present in relation A, B, C, D, E? Okay, now we want A, D closure. So then how do we take A, D closure? A, D, B, C, E. Okay. Now can we write A plus closure? A plus closure, we can write B, C, D, E. Yes. Similarly, can we write A, D, C, D closure, C, D, E. Similarly, can I write A, B plus closure A, B, C, D, E. So like this, we can write a closures of AB. Yes, so this is what is called as a closure. Okay, so this is what we have seen about closures. Okay, so that's what you can see here. So what did we see here? In this case, we have seen about informal design guidelines for the relational database, and we've seen about what is the guidelines. What is the first one we see? We told about the semantics of the relational attributes. So how should be the meaning of the attributes? It should be only one. So when we have seen this was an example, simplest example what we have seen. So that's what here in this case, we have seen about a company database where in that company, how many relations we have? We have an employee, department, department location, project, and works on. So what is employee? Employee name, SSN, birth date, address, and D number. So then we can see in the employee table, we have a SSN as a primary key and D number as a foreign key. Similarly, we have a relation called as a department. So we have a relation called as a department. One second. Yeah, so in this case, department, D name, D number, manager SSN. So then we can see how the department location, that is D number and location. So in this case, because we cannot have a uniquely identifying the rows, then we have combined both, then we call it as a candidate key or composite key. So D number and location put together to forms a primary key. Again, we can see here D number is again a foreign key from a department table. Then what is a project? Project is one more relation where project name, project number, location, and D number. So again, in the project, number is a primary key, D number, department number is a foreign key. Then works on. So what is works on? That is SSN and P number. Then this put together is called as a foreign key. Then SSN and the number put together is called as a, both the things we use it as a composite or a candidate key. I cannot uniquely identify rows in the works on. Instead of that, we use two. One is SSN and a project number. Based on these two, then we can uniquely identify the works on. So then we have seen about a redundant information in the tuples and the update anomalies. So mixing attributes, sorry, mixing attributes of multiple entities may cause problems. Information is stored redundantly, wasting storage. Problems with update anomalies can be insertion anomaly, deletion anomaly, and modification anomaly. So the example of example of an update anomaly. So consider the relation employee project. You can see here employee project E name, P name, and number of hours. So we want to update this particular anomaly, changing the name of the project, P number from billing to customer account may cause this update to be made for all 100 employees working on the project P1. So suppose you think that we want to change the project title from P1 project name, the project number is P1 and the name initially was billing. but now we want to change it to customer account. Then for how many employees are there? Suppose let us assume that there are 100 employees. Then changing 100 employees becomes very tedious. So that's what is a update anomaly. Similarly, so insertion anomaly, until unless suppose you think that we have started one new course and there are no students joined there, then how can we just create only table and there is no student there? Then we say it is a insert anomaly. Cannot insert a project unless a employee is assigned. Suppose you have a project, like you cannot insert. Suppose you think that you have your third semester student and you're doing some projects. So then based on this project, you're inserting the values. So then we say examples of an update anomaly. So in the same way, delete anomaly, suppose when a project is deleted, it will result in deleting all employees who are working in that project. Suppose you think that there are 10 people working on that. Now we will delete only project. Yes, if I delete the project because the project has got completed, but still there are some projects, some employees who are working for two projects. He is working for project one, he is working for project two, and if you delete that particular employee also, he will also be removed from project two also. Then that should not happen. So that is what is called as a delete anomaly. So you can see in this case, so two relation schema and their functional dependencies both suffer from update anomaly. The employee department and relation scheme, employee and project relation scheme, that is employee and department, that is ename, then SSN. So you can see what is the unique things we have in this when we are combined two tables, that is employee and department. So here the anomalies both suffers from update anomalies, even the employee department and employee project. Because once you update only department, it should also be updated in the employee. That's what we have just seen. If you are changing the title, suppose you are changing the title of a department name, then you have to update in all the 100 employees. Then it becomes very difficult. So the same way in a project also, if you're updating in the project also, it becomes very difficult. So I'll stop here. We'll continue in the next class. Answer your attendance. Test date is 9. 9. 9/11. Asta. Asta is present. Abhinav. Aishwarya.
Present, ma'am.
Amrish.
Ma'am, Amrish is present, ma'am.
Anu.
Present, ma'am.
Arbaz. Arjun. Ashok.
Present, ma'am.
Benita. Bhargavi. Bhavishya.
Present, ma'am.
Chaitra.
Present, ma'am.
Debmalai.
Present, ma'am.
Diksha.
Present, ma'am.
Deepika.
Present, ma'am.
Deepika MB. Murli Krishna.
Present, ma'am.
Gangubai.
Present, ma'am.
Pujia. Harshit.
Present, ma'am.
Chunjar. Kavya.
Present, ma'am.
Kishore. Lata.
Yes, ma'am.
Manisha,
Present, ma'am.
Manjunath,
Yes,
Nayana,
ma'am.
Present,
Nayana,
ma'am. Present, ma'am.
Neelanjan, Neelanjan, Nishant, Pavitra,
Present, ma'am.
Maithili, Priyanka,
Present, ma'am.
Pavan,
Present, ma'am.
Akash, Rajeshwari,
Present, ma'am.
Rakesh,
Present, ma'am.
Ma'am, Akash present, ma'am. I missed
Ramya.
the end call. Ma'am,
Yeah, marked Akash.
I
Ramya,
missed the end call.
Ramya, Rashmi,
Present, ma'am.
Ravi,
Yes, ma'am.
Rizwan, Vishal,
Present, ma'am.
Savita,
Yes, ma'am.
Shruti, Sneha,
Yes, ma'am.
Spurti,
Present, ma'am.
Srinidhi,
Present, ma'am.
Srinivas,
Present, ma'am.
Sunil,
Present, ma'am.
Vaishnavi,
Present, ma'am.
Vinny.
Present, ma'am.
How was your internals? How was your internals? Can anyone answer? No response. Why?
Ma'am, it was too lengthy, ma'am.
Too
Lack
lengthy.
of time. Yes, ma'am.
Then, but same way, even you have DBMS is always like that only. Not only theory, even the lab also it is like that only. Because you
Yeah,
have
ma'am. Other than good, but it's too lengthy to answer questions in 1.5 hours.
yeah, that's true. But nothing can be done with respect to DBM. There are some subjects like that only. Okay, rest. Other than that, lengthy, fine. Then some people have, because you people have submitted late, we have been given instruction that we should not give you marks. I don't know what they will do. We'll see. Around how many people? 9 people have submitted late.
Even me, ma'am. It's buffering too late, ma'am.
Yeah, you just give the same
5 to
reason.
6 minutes only. Yes, ma'am. Seriously.
Yes, we understood. We can also understand because when we are
Yes, ma'am.